Okay. So let us now understand. We know basic idea of virtual memory. We understood what is a page, what is a frame, what page fault is, how operating system handles page fault. So now let us understand the following. Whenever a program runs, it needs memory, but we know memory is limited. When all memory frames are occupied, a new page needs to be loaded, and that situation we called it as a page fault, and that's where the page fault occurs. Now, if there is no free frame available, the system must remove the existing page and replace it with the new one. And this decision is not random. It is handled by page replacement algorithms. There are three major approaches we'll focus on: FIFO, LRU, and optimal. The purpose of studying these algorithms is very important. Like, first, how can we see the page fault minimization? We want to improve overall system performance and to ensure efficient utilization of memory. So in this part, we'll understand how each algorithm works and how they differ from each other. Now let us understand this concept of page replacement. What exactly it means. Page replacement is a memory management technique used by your operating system. When memory becomes full and new page arrives, the system must decide which existing page should be removed. And this decision is taken using a specific algorithm. Why this is required? Because as memory space is limited, multiple processes are executing simultaneously. New pages keep entering in memory. So we cannot avoid replacement. Instead, we need a smart way to decide which page to remove. Different algorithms follow different rules for this decision making process. Simply, one can say a page replacement algorithm helps the system to choose the best possible page to remove when memory is full. So let us start with the FIFO. Let us begin with this first algorithm, first in, first out. This is the simplest page replacement algorithm. The idea here is based on the queue data structure. The page that enters memory first will be removed first. So memory behaves like a queue. New pages are always added at the end. Oldest pages are removed from the front. When memory is full and the new page arrives, the system removes the oldest page and then inserts the new page. This algorithm is easy to understand and implement. However, it does not consider whether a page is frequently used or not. It simply focuses on the order of arrival. Now let us take example. Okay, so let us say I have the page reference string given as 423, so on, like 423, 215, 246, 237, 215, 24632. Number of frames are 3. Now let us see how exactly it works. As the pages are processed one by one, as we stated that there are 3 frames. So you can see I have specifically used the color boxes. What is page fault and what is page hit? Page hit means what? Page is already in memory, and page fault means page is not in memory. So if the page is not present in the memory, there is a page fault. Okay. And if it is already present, then page hit. Okay. So let us see how it works. So I'm considering that there are 3 frames. So 4 is loaded, then 2 is loaded, then 3 is loaded. Then it says 2. It is in memory. You can see the color combinations and how exactly it works. Now, if you mark that page fault blocks, total number of blocks, 3 plus 3 plus 2 plus 1 plus 3 plus 1 plus 2 plus 2. you will identify that it is 17. So here, in this case, one can see there are total 17 page faults. Page fault means like the pages were requested, but pages were not in memory. Correct. So the using FIFO, what we did was the oldest page is replaced whenever needed. So after processing the entire reference string, the total page faults are 17. And this clearly shows FIFO does not consider the importance of pages. It may remove useful pages simply because they are old. So simple line to remember FIFO is the one who comes first lives first. That means line में जो आगे आया सबसे पहले वही हटाया. Correct? This is your first rule. And this enforces the FIFO idea. Now, uh, can you please note down this string? Note down this string. Let me see if I can add it. Okay. And then I expect you peoples rather to work with number of frames to be 4. Okay, I'm adding this in chat and you have to upload this into LMS. Fine. I'm adding the assignment. Now number of frames to be 4. Work out it, take a photo of it and you have to upload that into LMS. I'm adding you for you peoples where to add it. Please work out with 4 frames. Same string. I have added it chat window. Take a photo of it with 4 frames and then we'll check what is happening. You have to draw the diagram the way I have drawn. You can have say some marking there so as to show the page fault. You can add arrows. You have 5 minutes. Do it fast. Like in the text, you have to write number of page faults on that LMS. Fine. I have added that link for submission as well. Fine. You have to finish it before 10:35. Do it fast. I have added the link for submission as well. Capture the photo and upload it. Done with the case? One of you just submitted it. Do it fast. Two of you have submitted. So when the clock stops, you will not be able to submit it. Three of you submitted. 3 minutes are remaining as per the time that I have extended by you. So we are considering the same string. Okay, page reference string to be same. We got 6 people submitted. For your reference, probably let me keep this again. Eight, 9, 10, 11, 13. Last 2 minutes. So expected was what? Like you were supposed to submit for 4. If at all there are 4, like what will happen? Fine. So we got good number. 18 submitted. Last 1 minute.
Sir, sir,
Huh.
where can I submit it?
No, it's already there is time.
Uh, Not sure.
Yeah. Keep it with you. You can see send a message and delete the way that somebody with KU did in WhatsApp. Okay. Fine. Okay. The time is up. Like what was the number that you got? Add in chat window. The number of page faults. Everyone, those who could not submit within the time. 30 submitted. 31, 32, 34, 34, 34, 35. I hope it is closed now. Correct? 36, 37, 38. Yeah. Now, like if you see, like compare your answer with this and see whether it is correct or not. You can see on the screen now. Now here what we did is we increased the number of frames from 3 to 4 using the same reference string. So you will like the number of page faults would result to 16. If you check how many of you could get this, like the one who submitted there earlier, like with number of page faults to be 15 or 14 at some places, correct? If you see. So Par Burman said 15, correct? Then Sanika 15, correct? So how many of you could get the same way that is shown here? Most of you, correct? So is this correct? So if we see there is slight improvement here compared to 3 frames. This might give the impression that increasing frames always reduces page fault. But this is not always true. And that leads to us to an important concept. Like what we saw with page 3, number of page faults that we saw earlier were correct 17. Then when we increased to number of page frames to be 4, we got 16. So one may conclude saying that if we increase number of page frames, then number of page faults could be smaller. But this is not always true. And this leads us to an important concept, something called as Belady's anomaly. There exists a special situation known as Belady's anomaly. This occurs when increasing the number of frames leads to more page faults instead of fewer. This is surprising, but like you can say counterintuitive behavior. FIFO algorithm is known to suffer from this anomaly. So even if we increase memory, performance may not improve. It actually sometimes becomes worse. So let us consider this situation. We have a page reference string 12341. 2, 5, 1, 2, 3, 4, 5. If you see the number with 3 frames, we are getting page faults to be 9. And with 4 frames, when 4 frames are there, please check this. You will see the number of page faults are 10. Now this is for the string, like every time it may not happen, but again it depends. But FIFO in general is said to be suffering from this particular problem. So clearly here, more frames may result into more page faults, and this confirms Belady's anomaly. And this is a major drawback of FIFO. Fine. So what this anomaly is, increasing the number of page frames results in more page faults instead of fewer. Okay. But please understand, this is not true for every reference string, but it is true for most of the strings, reference string with FIFO, just FIFO only, first in, first out. Let us talk about now the second algorithm, the LRU. The basic idea here is what? It is least recently used. LRU takes a smarter approach compared to FIFO. Instead of removing the oldest page, it tracks how recently pages were used. The page that has not been used for the longest time is removed first. This is just based on the assumption recently used pages are likely to be used again. Pages not used for a long time seem to be less important. And this makes LRU more efficient than FIFO. Now let us understand LRU more clearly. Now here, let us keep in mind, it keeps track of usage history. It identifies the least recently used page. It replaces that page when memory is full. So advantage is like better performance compared to FIFO. Reduces unnecessary page removals. But disadvantage is it is very complex to implement and requires tracking of page usage. So simple way to remember, the page that has been forgotten for longest time is removed first. So जो सबसे देर याद आया वही सबसे पहले बाहर गया. Fine. So let us see through the example. Now same reference string, number of frames to be 3. You can compare with the results earlier one. Correct. So let us see what are the number of page faults. So page faults are 15. With 4 frames, you can try this with 5 frames too. So it is expected same reference string, FIFO 5 frames, LRU 5 frames, 3, 4, 5, 3, 4, 5. Solve it, and towards end, rather within 20 minutes, you have to upload everything together. Okay, so this is for LRU. Now, if you compare this with FIFO, FIFO with 3 frames, we had 17 faults. LRU, we had 15 faults. So LRU clearly performed the better. So also LRU does not suffer from Belady's anomaly. Okay, this is least recently used. Now the third algorithm, it is optimal. This is the most efficient algorithm said by majority of researchers. This algorithm uses the future knowledge. It removes the page that will not be used for the longest time in the future. So when a replacement is needed, the system predicts the future usage, removes the least useful page, and this results the best possible performance. Now the key characteristics here, it gives minimum page faults. It is considered the best possible strategy. However, it is not practical because future page references are unknown. Now let me use the same reference string with 3 frames. Now here the idea as I stated was भविष्य देखा फैसला लिया बेकार पेज को बाहर किया. So here we are having again same reference string with 3 frames. Let us see how it works. So you will identify the number of page faults would be smaller than earlier two algorithms. One can say lowest among all algorithms. Like FIFO, we saw 17, LRU, we saw 15, with optimal, you see 12. And this clearly shows efficiency of the optimal approach. So to summarize our discussion, page replacement is necessary when memory is full. FIFO is simple but inefficient in some cases. LRU improves the performance by using the past behavior. And optimal gives the best results but is not implementable in real systems. Now, there are other algorithms too, like most frequently used. Again, one of the algorithm, but I'm not concentrating on other algorithms. You can definitely go through them once you have free time. The main goal of these all algorithms is to reduce the page faults, improve system efficiency, and optimize memory usage. Understanding these concepts helps in designing efficient operating systems. And so these are your all page replacement algorithms.